those couple of definitions and stuff that we'll have. Okay, so we talked about terms like midpoint, bisector, congruent, all those kind of terms. And we have talked in the past about slope and making graphs and putting points on a graph. And today we're going to connect those together and come up with a formula for two of the topics that we talked about so far, which is slope and midpoint. Okay, so that's what we're going to talk about today. For slope, starting with slope. Remember I said on when we first talked about slope that we should talk about slope as change in y over change in x. And that's the way we talked and thought about slope. And so, if we're thinking about change in y over change in x, then our slope formula should be change in y. Well, if I want to know the change from one number to the other, then we're going to subtract them. That's going to be change. Change in y will be take the y coordinates and subtract them. If I start with 4 and I end with 10 and I want to know how much it changed by, well, I'd subtract 10 and 4 and I'd get 6. Changed by 6 from 4 to 10. So when I say change, that means subtraction. So we're going to subtract our y coordinates over subtract our x coordinates. That's the formula for slope. And this is a formula that you should be familiar with. And just so you know, in case you forgot, these 2's and 1's, they're called subscripts. When we talk about y2 and y1, or y sub 2 and y sub 1, it's just meant to distinguish the coordinates from each other. It's meant to say y2, well, this is your second y coordinate, and y1, this is the first y coordinate. It's just being able to tell apart which y coordinate we're talking about based on how we label the points. But the basic idea of the formula is going to be subtract your y coordinates or subtract your x coordinates. So we've done it with the graph. Now we're going to do it without the graph. Now I'm just going to tell you the coordinates of the points, and you're going to use the formula to get them. The other formula that you should get is the midpoint formula. To get to the midpoint's going to be exactly halfway in between our 2 points. Midpoint is going to be exactly halfway in between. So that means we're going to take the average of each of the coordinates to find where exactly the middle is, where exactly halfway in between is. And so how do I find the average or the mean of two numbers? Well, we'd add them together and we'd divide by 2. That's how we'd average two numbers together. Again, to take the example again, if I want to know it was halfway in between 6 and 10, then to average them together, I'd take 6 and add 10 to get 16, and I'd divide by 2, and I would get 8. So 8 is exactly halfway in between 6 and 10. So we're going to do that for the x coordinate. What's halfway in between the two x coordinates? And what's halfway in between the two y coordinates? So to get out the x coordinate, we'll add the x coordinates we have and divide by 2. To get out the y coordinate, we're going to add together the y coordinates we have and divide by 2. Average of the x coordinates, average of the y coordinates. That's your formula for midpoint. So just to give you visualizing that again, I'm going to drag this point around. And you'll notice that the green point is the midpoint between the red and the blue. The green point is our midpoint. And so you'll notice that regardless of where I drag this point around, so let's keep it there, or if I drag this red point around, to get the midpoint, I'm going to use the same method every time. I'm going to figure out what's exactly halfway in between for the x coordinates, and then what's exactly halfway in between for the y coordinates. And that will tell me where the exact middle is. So those are the two formulas that we're going to concentrate on using and being familiar with today. And tomorrow, when you tune into the notes, we're going to look at the distance formula and how that formula works and where that formula comes from. How to find, here's 2 points, how far apart are they? But let's look at some examples with slope and midpoint, because those are the two that we're going to focus on today. So I'm just going to look at parts A and B. Now we're in examples in the notes. Now we're looking at examples in the notes. So it should be your first example in that packet. Slope. We use M as an abbreviation for slope. Remember, slope is change in y over change in x. So subtract your y coordinates over subtract your x coordinates. And so let's label these points. This is x1 and y1. And we remember that because this is our first point that we're labeling. So here's the first x coordinate. Here's the first y coordinate. So I would label it x1 and y1. That's all the 1 means. Here's the first point we're labeling. x2, y2. There's the second point we're labeling. And that's the x coordinate of the second point we're labeling, and that's the y coordinate of the second point we're labeling. So that's what we're going to use in those formulas. y2 minus y1 over x2 minus x1. Subtract your y's over subtract your x's. y2 minus y1. So we subtract our y coordinates. Subtract our y coordinates. y2 is going to be 0. Minus, subtract your y coordinate here, we have 4. Over, subtract the x coordinates. X coordinate here is negative 5. Minus our other x coordinate, which is a negative 2. So we're going to end up subtracting a negative 2. We should have two negative signs there because we're subtracting whatever that coordinate is, and it turns out that the coordinate we're subtracting is negative. So subtracting a negative 2. Equals 0 minus 4, that's a negative 4. Negative 5 minus a negative 2 would be negative 5 plus 2. So it's going to get less negative. Negative 5 minus a negative 2 is going to be negative 3. So we have negative 4 over negative 3. Negative divided by negative is a positive 4/3 for my slope. Midpoint. You'll notice that the formula for midpoint has addition in it. instead of subtraction like our other formulas are going to have. Remember, midpoint comes from averaging our coordinates. So to find the average of the coordinates, we'd add them and divide by 2. That's how we'd find the average. So that means we're going to take x1 plus x2 over 2. So take our x-coordinates, add them together. I got a -2 and a -5. I'm going to add them together. Those are my x-coordinates. Add them together, divide by 2. Same thing for the y-coordinates. My y-coordinates are 4 and 0. I'm going to take 4 and 0, add them together, divide by 2. Which equals, we got -2 and a -5. -2 plus a -5 is going to be a -7. If I take a negative and add a negative, it should get more negative. Over 2. 4 plus 0 is 4. 4 divided by 2, well, that's going to be 2. So -7/2 2 is our midpoint. So let's put these on our graph and see if our answers that we got for our formula make sense here. We've got -2, 4, so -2 up to 1, 2, 3, 4. Here's point A. -5, 0. -1, 2, 3, 4, 5. And then 0 means we don't go up or down, so that stays where it is. There's point B. So that's what our segment looks like that we're working with. Slope being 4/3, yeah, that makes some sense. Slope should be, slope of 4/3 means it's positive, means it's going up from left to right. And 4/3 means we're going up 4 and to the right 3. Up 1, 2, 3, 4, and to the right 1, 2, 3. There we go. So 4/3 does make sense for our slope. Let's check our midpoint. So point M, our midpoint, should be exactly halfway in between. Let's take a look. -7/2, let's see. 6/2 is 3, and 8/2 is 4, so 7/2 should be 3.5. So -3.5, -1, 2, 3.5, and then up to 1, 2. That looks like it's about halfway in between. And our midpoint should be on the segment. If it's somewhere else off the segment, then we probably did something wrong. So instead of doing all the work on our graph, now we're getting a formula and using the graph to double check our answer and make sure that it makes sense. That's our process here. We're only going to do parts A and B today because we're just focused on here's the slope, here's the midpoint. Tomorrow, when you tune into the notes, we'll take a look at distance. Let's do one more. And remember, we said we're going to use the graph as a way to make sure that our answers make sense. So we're especially going to do that here. Because you should be able to look at the graph and make a good guess as to what our answers are. 0, 3, and 4, 3. 0 up to 1, 2, 3. And x-coordinate of 4 means we move to the right 4. Y-coordinate of 3 means we move up 3. So here's A. Here's B. And so you should be able to use this picture to get a good sense of what the slope is probably going to end up being. Where's the midpoint going to end up? If we're thinking ahead about distance tomorrow, if I asked you how far is it from A to B, you probably have a guess as to what the answer is going to come out to be. And so we'll look at that tomorrow and see if it turns out to be true. Subtract your y-coordinates over subtract your x-coordinates. So the first coordinate here, here's the x-coordinate of the first point. Here's the y-coordinate of the first point. Here's our second point. So here's its x-coordinate. Here's its y-coordinate. So slope's going to be change in y over change in x. I'm going to subtract my y coordinates. My y coordinates here are 3 and 3. I'm going to subtract them. Over, subtract your x coordinates. X coordinates here are 4 and 0. I'm going to subtract them. So let's simplify that. We got 3 minus 3 is 0 on the top. 4 minus 0 is 4 on the bottom. 0 divided by 4, well, that's going to be 0. And looking at our graph, that should make sense that our slope is 0. Because if we're asking, remember slope is our measure of steepness, we're asking how steep that is. Well, it's not steep at all. It's completely level. And so it shouldn't have any measure of steepness. It shouldn't have any slope. It should just lie flat and be 0. And that's what we get out when we put it in our formula. Let's look at midpoint. Our midpoint is we add our x coordinates and divide by 2, and then add our y coordinates and divide by 2. And you do need the parentheses and the comma there, separating. Because remember, the midpoint is a point. At the end, when we get out the answer in our formula, it should be a point. It should have an x coordinate and a y coordinate. So we're saying, look here to figure out how to get the x coordinate, look here to figure out how to get the y coordinate. That's why we have the parentheses and the comma separating them. So once we get out the coordinates, we can just take the point, put it on the graph. Add the x coordinates, divide by 2, then add the y coordinates, divide by 2. X coordinates are 0 and 4, so we're going to add them, divide by 2. Y coordinates are 3 and 3, so we're going to add those together, divide by 2. Zero plus 4 is 4, divided by 2 is 2. 3 plus 3 is 6, divide that by 2. 6 divided by 2, that's 3. So 2, 3 is our point. Let's see where 2, 3 ends up being and see if it makes sense as splitting this segment in half. X coordinate of 2 is here. Y coordinate 1, 2, 3. Bingo. Again, remember that a midpoint's going to split it exactly in half into 2 equal pieces. So these pieces are congruent, and we mark that with little tick marks like that. So these 2 pieces should have the same distance between them. We'll talk more about distance tomorrow. So that is your slope formula, your midpoint formula. Any questions on those? All right, flip your notes to the back again. Like I said, tomorrow we're going to talk about distance. So that means that I need to tell you something about square roots because our formula is going to involve square roots. Let's talk about simplifying radicals. So when I say radical, I'm talking about this symbol right here, this square root symbol. So if I talk about something inside the radical or simplifying the radical, I'm talking about the symbol that you use when you write a square root. That's a radical. And let's start with an easy example here. First example. Square root of 12. I want to simplify square root of 12. What I'm going to do here is I'm going to call this, when we talk about it, I'm going to call this building a tower. And what I mean by that is that we have I'm going to write 12. I'm going to put it in a little division symbol. And I'm going to build a tower of dividing. And what's really going on is something that's called, in arithmetic and algebra, prime factorization. We're taking this and we're breaking it into the smallest pieces multiplied together that we can. In terms of our tower, we're going to make our tower as tall as possible, which means we're going to start by dividing in our tower. We're going to divide. Let me do that again. In our tower, we're going to divide by the smallest numbers that we can. This will give us prime factorization. So the smallest number we'll divide by is going to be 2. 1's not going to help us because divided by 1 doesn't do anything. So we're going to start with 2. We're going to see if we can divide by 2, and we'll keep dividing by 2 until we can't divide by 2 anymore. And then we'll see if we can divide by 3. And then we'll keep dividing by 3 until we can't anymore. When we know we've hit the end is when we've hit the top, when we've hit 1. 1 is the top of our tower. So let's do this with 12. For 12, I look first to see if I can divide by 2. I can. And we get 6. Remember, we keep dividing by 2 until we can't divide by 2 anymore. I can divide 6 by 2, and I get 3. See if we can still divide that by 2. No, we can't divide by 2 anymore. But we can divide by 3 by 3. And that gives us 1, and 1 is our top of the tower. Circle, pairs. Before I go into detail, I want to explain what is happening here. What we're doing is that we're writing 12 as 2 times 2 times 3. And what we're doing is that we're looking for what's called perfect squares. Because if I take the square root of something that's a perfect square, then it just comes out of the radical. The square root symbol goes away. So if I have something like the square root of 16, well, that's just 4. And I don't have a square root anymore. That's our goal, is to find things, break this into pieces that will have the square root just go away. So in this case, I notice that this pair of 2 times 2 gives me a perfect square of 4. So this equals the square root of 4 times the square root of 3. Well, I know that the square root of 4 is just 2. Square root of 4 is 2, no more square root there anymore, but I still have the 3 inside the square root. That's the algebra of what's going on. That's the mathematics of what's going on. Here's the idea that's going to help you remember it. Is anytime you have a pair, you're going to wind up with this perfect square situation where the radical is going to go away. So if I have a pair of 2's, that means that this 2 is going to be able to come out of the square root. If it doesn't have a pair to go along with it, it's got to stay inside the square root. And the way that I have to remember this is what I like to call the rules of dating, which is couples go out, singles stay in. If I've got something that has a pair with it, like this 2 has got a pair with it, so it's a couple, it can go out. That couple can go out. But I have this 3 over here, oh, it's all by itself. It doesn't have a pair to go along with it, so it's got to stay in the square root. So that's the idea. Anytime you have a pair, that means you'll be able to take it out of the square root. it doesn't have a pair to go along with it, can't go in the square root. Let's do another one so you see how this works. Square root of 72. I'm going to go a little bit quicker this time through the steps, but the steps are going to be the same. Let's build our tower. Remember, divide by the smallest number you can until you can't divide by it anymore. So we have 72. I'm going to see if I can divide that by 2. Can I divide that by 2? Yes, I can. So if I divide that by 2, 72 divided by 2, that's going to be 36. Can I still divide that by 2? Yeah, we can. We divided by 2 until we can't do it anymore. So I can still divide by 2. And we get 18. Can we still divide by 2? Yes, we can. I can divide that by 2, and I get 9. Can we still divide by 2? No! We can't divide by 2. But we can divide that by 3. That's the next smallest number we can divide it by. And when I divide that by 3, I get 3. And we can still divide that by 3. And we get 1. 1 is our top of the tower. Tower's a little taller this time, but we're still going to do the same thing. We're going to circle our pairs. I've got a pair of 2's here. This 2 doesn't have a pair with it, so I'm not going to circle it. But these 3's, they're a pair. So what I have outside the square root is I have a pair of 2's, so I'm going to write a 2 outside the square root. I got a pair of 3's, so I'm going to write a 3 outside the square root. And then inside the square root, I've got a 2. It doesn't have a pair with it, so it's going to go inside the square root. Anytime you have things together outside or inside the square root, you just multiply them, because what's happening is multiplication. So I've got the 2 and the 3 outside the square root. I'm going to multiply them together to make 6. Square root of 2. And that's how we can simplify. 6 square root of 2 is our answer. So this formula is going to use square roots. If you want extra practice, I'm going to make a video tomorrow evening where I go through a couple more examples of simplifying square roots. Tomorrow in class, we're going to talk about the distance formula. So if you need extra practice with how to